very happy to introduce the next two speakers. It's on the one hand, Dr. Leif-Nissen Lundbæk, and on the other hand, Professor Michael Huth. They are both working at Xayn. Xayn is a company dealing with search algorithms and with search in general, and they are talking about reinventing web search with convenient, controllable, and privacy-protecting AI. We're very happy to hear their insights. The stage is yours.
Thanks very much, Lucas, for the introduction. So we're pleased to present our work on reinventing web search. So this is really about, bringing convenience, controllability, and the protection of privacy through AI to the domain of web search. So what's really the most essential part of the internet? Historically, this was, of course, protocols and all those kinds of things. But if we think of the today's users, what is the thing that they use most? That's really web search. So just a couple of figures. There's about 30% of all the global, activity on the internet is around searching, entering queries, trying to find information. Also, if you look at the most popular websites that are visited, 4 of them out of the top 10 focus on search. What's also interesting here is that the global search market share of Google is now at 86.6%. And so we can see that that share is actually dropping over the years. So this is maybe also indicative of some change. Also, lots of companies now have need for accessing documents and information internally, but maybe also combining that with search for information that's on the internet. So there's some real opportunities here in new technology where AI can improve things. So let's look at the space in a bit more detail. There's actually a dilemma here between privacy and convenience. So on the left, we have players like Google and Bing, and their focus is really on a very superior convenience and user experience, where that's gained by leveraging a lot of data from the end users to get a personalized experience of web search. And that works very well in that regard. But the issues we see here are really that there's an exploitation of user data that gets a massive user pushback. So one example is actually WhatsApp India, where they were trying to change their terms of service, linking this and integrating this more with other Facebook services. There was a huge backlash that actually wasn't just confined to India, but was basically a global kind of movement. And that's indicative of some kind of change we see also in social behavior, including in Northern America and the United States in particular. Also, these business models are at odds with privacy. So on the other hand, on the left, we see privacy as an attempt, startups like Niva, Startpage, and DuckDuckGo. So there, they provide privacy by not tracking any data. And so that gives protection in terms of privacy. For example, anonymizing any kind of queries in terms of their provenance before sending them to some APIs like those of Bing and Google. So really, the issues we see here is, while that's sort of feasible and gives some protection of privacy, it basically doesn't leverage user data and, the personal sort of predilections of end users. And that's basically giving us an inferior experience in the web search. So really, if we take these two things together, users are always, in a sense, the losers. So either they actually lose control over their data, when we have this kind of very convenient tech for web search, or they lose their time, because they don't get very insightful search results. So they have to refine searches and so on at the expense of privacy. So that's really where we come in. So Xayn is an app you can find on the Apple and Google Play Store. We're really solving this dilemma here through AI. So on the left, the first thing to note is that any AI that is on the app is actually in the app. So it's on the edge. It's on the device. So this is not something that happens, at our servers or anybody else's servers. It's really something that the user runs within their phone. The second thing in the middle is, the search results get personalized by the integration of 5 different AI modules. And Leif will go into the details of that in the second half of the talk. And thirdly, the user really is in control of the search. Yeah, so there is a Tinder-like left-right swipe expressing interest. Also, our app allows for filtering down certain topics or domains to restrict the searches. At the same time, the AI has one component that gives us a lot of sort of discovery elements so that these things aren't trapped in a kind of filter bubble. And now, with this in hand, I want to say, Leif will basically go into the details of these 5 AI modules and how the personalization really is brought forward there. But there are also some aspects here that are sort of the wisdom of the crowd. And this is something we can leverage through our open source framework, Xayn, which is masked federated learning. And so the idea here is that all the raw data stays on the device, on the phones. The AI models are trained locally, for example, in a domain understanding domains of information a bit better across users. And then these models actually get sent to a central site and get aggregated to gain more insights. And that's being pushed back again into the apps for better understanding and a better experience. So the advantage of this kind of framework is that it protects the privacy of users and also that it works asynchronously. So we don't have these overheads associated with conventional frameworks in this space. And we also have cryptographic randomized elements in there that protect against attacks where someone might, for example, poison data once they've manipulated maliciously the app, say. So with that, I think it's time to hand over to Leif to continue the presentation.
Yeah, hi. Nice to meet you as well. And so perhaps let's have a look a bit deeper into how this entire application itself is actually learning about user interactions. And one of the most crucial things that we had to solve was actually this kind of user-centric learning. Because usually, of course, when it comes to personalization and search engines, for example, usually you apply some kind of, on a global sense, cross-user pattern matching, right? So you try to basically see what previous users have done and what they actually at the end clicked at, for example, or what they liked. And you try to basically apply this also to new users. So you kind of solve also this kind of cold start problem. But the cold start problem is eventually, of course, a problem for us, really, because we don't know anything about the user beforehand. So we only have to kind of learn extremely quickly based on the user interactions that one user is doing. And this is extremely critical because it's actually kind of like a blind flight, if you will. So we have actually a very small data problem, and we have to extrapolate based on this small data as much as possible. So it was not really possible to solve this problem with conventional technologies or conventional models where you usually just apply, for example, one AI model to kind of learn how to rank results in the best way. But we actually had to kind of develop a team of AI models, so kind of like a composition of AI models, where the output of the first model is then used by the second model and so on. And the complex or the system was extremely complex also to develop. So it took us actually over a year also in stealth mode first to kind of develop the first version. And what you find is that we have this challenge always in our system that we have to learn in less than 10 interactions. And that's basically the disadvantage. But the advantage that we actually have is that we only can focus on one single user. And we know that the data from one user is actually much more precise in our case. So we actually go one step ahead here, and we apply kind of hyper-personalization style, where we personalize to a very, very large extent. That, of course, also leads to certain problems. So because, of course, we want to also prevent that we don't only show content to a user that kind of leads to in a kind of like filter bubbling scenario. So we also developed a system that kind of takes all of these inputs from the first model. So from the kind of learning which kind of domains you like. Do you like, for example, rather CNN or Fox News, although they have kind of almost the same content? And of course, what kind of context do you really like as a user? Do you like specific, I don't know, like very, very fine-grained sports, or do you like rather certain politics? Do you like them in specific countries and not in other countries, etc., etc.? But the problem is, of course, that if you really push this too hard, you really end up into kind of like a filter, really. And therefore, we also added a dynamic contextual multi-armed bandit, which always switches between exploitation of knowledge and also kind of exploring of new situations. So also showing users content which they might not actually like, and you have also kind of good reasons to estimate that they might not like it, but actually maybe also their interests have changed. Maybe also the AI was wrong. And therefore, I think it's a very, very interesting, very important composition here. And if you could go one slide forward, please. Yeah, so in general, kind of we have this small data problem. So I always also frame us as a small data company, actually. And we have this kind of challenge of learning extremely quickly. And also, of course, another challenge is that we actually had to shrink also these AI model sizes really to an enormous extent. So if you combined all of these AI models together and you wouldn't really apply any technologies of, for example, distillation, of kind of merging the embedding sizes, et cetera, then you would end up with an enormous model size. And of course, that's not really fitting into, for example, a mobile phone or a smartwatch even. And so what we did was applying multiple technologies in order to also shrink the size from standard technologies like distillation, but also very unconventional ones. For example, the merging of the embedding spaces of multiple different languages into one single embedding space, so that we can actually kind of picture multiple documents that can be in any kind of language, for example, Italian, French, English, and we all picture them in the same embedding space. So we can have actually multiple documents in different languages and have the same understanding of them, which is of course very important because especially on the European side, you might actually use different languages all the time. And also, of course, another problem is that we had to increase the model or speed really on the edge side by over 5,000 times in total in order to make it almost kind of seamless for the user. So we do this by using frameworks and by also kind of looking kind of at the different chip level instruction sets kind of at installation time so that we can optimize these models to run as fast as possible on different chip levels. So we don't, we obviously cannot use technologies like TensorFlow, and we had, of course, to develop a lot of these things from scratch also. And so it's basically written in Rust also so that we can apply this also in all sorts of different scenarios, from, of course, native environments to WebAssembly running in a browser on the client side. And of course, another advantage is, and that might be not so obvious in the first side, is that, of course, at the end, it is actually pretty scalable because we can, we actually don't really have any server costs. We don't have any cloud costs on that side. You might think, okay, actually everything is kind of used on the user side, and actually the user is paying for this. However, we also compared this, for example, to Google. So, for example, to the Google app, and actually it's even less energy consuming than Google, because they, of course, have to transmit all of this kind of data to the server side, which is, of course, costing also a lot of energy. So at the end, everyone is actually saving a lot of energy and a lot of cost in this kind of scenario. Yeah. Another very interesting aspect, which actually this kind of hyper-personalization is allowing us to do, is to focus on a very specific area of search. So in general, we see different search behaviors from quick search. So for example, you might want to look something up like, I don't know, how do I install Dropbox, or how do I switch from WhatsApp to Signal or so. And this, of course, you kind of know what to expect from an answer. So it's kind of easy in order to kind of show you what's the best answer here. But also, there's another type of search behavior, which is more explorative search. You might also call it browsing, for example, or actually deep search, where you actually don't really know how the answer might look like. Sometimes you don't even know what to ask, really. So just imagine you, I don't know, want to learn more about climate tech. And you have first maybe not really an idea what's going on the technology side there. And then you search for this just on the top level side, and you find out, okay, actually there is some technologies around battery technology, maybe carbon absorption, things like that. And you want to learn more, you want to dig deeper into it. So you can, with Xayn, click just on the document and go deeper and deeper and deeper. And we also launched this feature in a couple of weeks. And I think this is one of the nicest things actually about it, because you don't have to refine your search all the time, but you can just dig deeper. Of course, and this is actually one of the areas where hyper-personalization is extremely useful, because every of these documents has all sorts of different modalities, really. So it's so different topics, if you will, and you have to kind of decide in which direction to go and which direction is really fitting for the user. And yeah, so this is, I think, one of the core aspects really about Xayn. And yeah, so just a few words about Xayn. So we're kind of coming from research, really. So we're also like the creators of XaynNet. So we actually are very, very much like a transparent and open company. So develop most of our things in the open source side. We originated from research, but we moved pretty much everything to Berlin. So the team is mostly also now located in Berlin. We, of course, are also from our DNA, still very much on the research side, so with a very high PhD quota, of course. And yeah, so, but if you also, I mean, we're actually pretty proud on our privacy policy, because you will see that we actually track nothing at all about the users, and everything remains with you. And plus, of course, having this kind of controllability, which I think is one of the core components. Thank you very much. And yeah, perhaps you have also some questions.
So thanks a lot for those very interesting insights in your way of dealing, or way of looking on operating in the search engine market and ecosystem. So maybe one question would be, which is very interesting from my point of view, is how do you see the development of search engine ecosystem market in the next 5 to 10 years? And where is Xayn being, what do you see Xayn in this ecosystem in 5 or 10 years, like as we see this progressing, your company and your projects?
Well, if I may answer, I mean, this is, I think, like a very, very interesting question also, because I think actually the search space is becoming extremely diverse. So you will have actually everything between pure, I would say, like Google-driven companies that actually provide basically, of course, as much convenience as possible, and kind of whether the user is actually the product, I would say. So the user is, of course, leveraged, and the data of the user is sold to whatever company. And of course, I mean, there is also good reasons for that, and there will be also in the global market a lot of people that, I mean, not care is maybe the wrong word, but where it's totally fine for them. And then on the other side, I think there will be also a much growing percentage of users that say, well, I do everything for privacy, and that are really kind of want to have this kind of change on also. And I think this is there is a very, very big space also in the future for companies, for example, like DuckDuckGo. And when it comes to Xayn, I think there is also a lot in between. So we try to basically bring privacy more to the mainstream market, because there's a lot of users that say, well, I actually want to still have this kind of convenience. I want to have privacy, but I wouldn't do everything for it. And I still value basically convenience over privacy. And we try to basically bring an offering into the market for exactly those users that want to have really both. And I think there will be also more companies like that. And we already see this, for example, with Niva in the US. And of course also DuckDuckGo further growing. And so I think the search market itself will be a lot more diverse. another factor that has like right now a very, very big influence over that is that the network effect that you saw in earlier years in the search market, and that actually Google was kind of introducing to the search market, is kind of gone. So the network effect was introduced by the search by the page algorithm, where of course kind of this kind of network is built up, and you kind of have like more relevant pages that link to each other and so on. But we saw already in the past years that with the introduction of better NLP models, that even Google itself was switching away from this PageRank algorithm, and therefore I think there will be not this one dominant player that has like this 90% market share. I of course think Google will still have a very, very big role in the market. However, I think it's impossible for them to keep this market share for very longer.
So thanks a lot for those very interesting insights in your presentation, and also your considerations in the end. Thanks a lot, and have a nice day.
Thanks, Lucas. You too. Bye.